So here is by Coulombs law, Q1 Q naught upon R square, you can say E upon F, or you can say Q, no problem, this you can say. So from this Q1 is cancelled. So E is equal to, we have 1 upon 4 pi epsilon naught K into Q1 or Q upon R square. This is Newton per Coulomb. It's a unit of the electric, and this is a vector quantity, so you can put the sign of vector. So here we have studied the Coulombs law. The product of the charge directly proportional and inversely proportional to the force is square of distance. Combine these two. Here K is a constant, Q1 Q2 from where we can define, okay, and it is valid only for the two conditions which have earlier we have stated, and the electric field due to a point charge is this one. Pause. So in the previous, the electric point charge, electric field intensity due to a point charge. Now here we will talk about the two position of the charge. In which two position we have to find the electric field intensity. Intensity, that means the area around the conductor where the force is experienced, unit per area, or it is situated in two. Number one, side on position. In the side on position, suppose this we have a dipole, okay, and number two is a broadside on position. So this is called the broadside on position, right? Here A and B, this is minus Q plus Q O, and this is a point P. We have to find the electric field intensity here. The distance of OP is R, okay. This is a 2A total, A plus A will become 2A, and this is a, this is a B. The distance between them A plus A will become a 2A, and this is the electric field intensity dash 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 infinitely point. So here the electric field intensity can be determined in the two ways. Number one, side on position, number two, a broadside on position. Now we will talk here about the dipole. What is a dipole? As the name, a system which consists two equal and opposite charge at a smallest distance 2A. Such system is called dipole. Like this we have A, this we have B, minus Q, and this is plus Q, placed at a smallest distance 2A. So this system is called the dipole. It is equidistant from the center, this point O. This is A and this is A. This total become a 2A. So system is called a dipole. And second one is a dipole moment. M-O-M-E-N-T, dipole moment. The product of charge and the smallest distance is called the dipole moment. It is represented by P, and it is a vector quantity. So P is equal to 2A into Q. Just we have seen the product of smallest distance and charge, or charge and smallest distance, is called the dipole moment. It is represented by P. It's a unit. See that this is a length, so C meter, and this is a charge, so Coulomb. This physical quantity have its a unit cm. This question asked is many time in the objective. Which physical quantity have its unit cm? Is it vector or scalar? So answer is dipole moment. Its unit is cm. C means Coulomb for the unit of charge. M length, unit of length is meter. Earlier 11th you have studied. So cm, and it is a vector quantity. Dipole, a system of two equal and opposite charge kept at the smallest distance. Dipole moment, product of charge into. And now again we will talk about here electric lines of force. So what are the electric lines of force? A simple answer. Electric lines of force are those imaginary curve at which positive charge can move. Electric lines of force are those imaginary curve at which positive charge can move, and they have the following property, and these properties should ask in an objective. So learn this very well. Number one, they do not intersect each other at any point. Electric lines of force do not intersect each other at any point. Second property, if they intersect, there will be two field and two direction, which is impossible for a positive charge, single charge, it is impossible. Third one, their denseness shows the maximum intensity. How much they dense, they will show a maximum intensity. Next, they start with positive continuously for the plus q. So plus q, the electric lines of force always goes outside from the system or from the conductor. For the positive q charge, they always goes for outside, and for the negative charge, if we have negative charge, then the line comes inside. So for here is q is greater than 0, draw the electric lines of force. So you have to draw this positively outside the field, and for the negative charge or q is less than 0, you have to be inside the. These two structures very important, they ask in the 1 marks question every time they have asked.